Hey, Taoping Airlines Math Industry, and we're going to look at a new formula for math. The new formula is volts equals current multiplied by resistance. With this formula, we get to measure the strength of the electricity inside something. Before we get into solving these problems, we have to know the definitions of what a volt is, what a current in amps is, and what resistance is. And we also have to know what a battery is. Or actually, this is called a cell, because the cell is actually the main charger or the main engine for this machine. And this is a circuit right here. So this is not a battery until it gets placed in here. So what the formula wants us to understand is how much power or how powerful are these batteries delivering the electricity into these loads. The load is like a light, a motor, TV, computer, Wi-Fi router, phone, clock, printer. So pretty much a load is something that uses electricity to work, like your home appliances. So with a cell, that's why the company is called Duracell, it will show you how much volts this battery has. So let's try and find how many volts it is. There it is, 1.5 V. The V symbol represents volts. And this AA battery made by Duracell is 1.5 volts. The definition of volts is that volts represents the power, the charge. How powerful is this battery? Or how strong will this battery be to activate a load or appliance in your house? So remember, voltage represents how strong the battery is, or actually how strong the cell is, I mean. So that's why you see in some areas it says high voltage, because when there's a high voltage, it means that it has enough strength and power that might electrocute you if you touch it. So this cell has 1.5 volts. If you want to increase the power of the cell and deliver it to an appliance or like a load, like in a refrigerator or something that works on electricity, you're going to have to add in another cell. So 1.5 plus 1.5, these two batteries will now give a power of 3 volts, because 1.5 plus 1.5 is 3. If we add in another battery and we all connect them up together, 3 plus 1.5 is 4.5. So each time there's another cell connecting each other, it will deliver a more powerful charge. Moving on to the amps. So with the I, the reason why they didn't use C for the formula is because C is already taken. So they used I in place of current. So what the definition of current is the flow of the electric charges. So the electric charges get to flow through these and get into these, which will eventually power up. Current also measures the speed of electrons from getting from origin to destination. Amps measure how much or how many electrons will go through a given point in 1 second. So remember, the current is an electric charge that will go from cell to load. or cell to light bulb, for example. So if you play Pikmin 3 on a Nintendo game on the Wii U, you might have realized that yellow Pikmin are really good at conducting electricity, and they can make a current that went from the Pikmin to the light bulb. So that is an example. The last letter that we're reviewing is resistance. That is an R. So with resistance, that means it matters on how much pressure the wires have, because electricity goes through wires and these metal conductors, and they go through them. So with resistance, that measures how much pressure the electricity is going through. Here's an example. If you compare a hose and an electrical cord, the wires is gonna have more resistance, because if you picture a water hose, water does move like freely through it, but with electricity, and if you make it go through a wire, the wire has less room to move around, and therefore it's more strength and there's more pressure inside the wire. So the smaller the medium, or the smaller the object goes through, the more resistance.
No, Ari, he can't drink it all.
Augusto, sweetheart, save some room for later.
Oh, Augustus, please, don't do that. My chocolate must never be touched by human hands. Please, don't do that. Don't do that. You're contaminating our entire river. Please, I beg you, Augustus.
Blowing up the pipe.
Call a plumber. Stuck in the pipe there, isn't he, Wonka? It's his stomach that's done that.
He's blocking all the chocolate.
Oh, what happens now? Well, the pressure will get him out. Terrific pressure is building up behind the block. Remember you once asked me how a bullet comes out of a gun?
So, if you watch Charlie and the Chocolate Factory, that pipe the kid was inside, that was supposed to represent resistance. Because when the kid was inside the pipe, he made all the chocolate block so it wouldn't flow, so it had a lot of resistance. And whoosh! So that explains the whole formula and what volts, currents, and resistance mean. So this is going to be the end of this video, and there will be the second part where we actually get to solve a math equation out of this formula. This video was supposed to help you understand the definitions of what the letters represented. Thank you for watching Taoping Airlines Math Industry. Like and subscribe. And we like to give Izzo Electric a shout out. An electric company in Rhode Island.